Hi, welcome to Wrenchin Up, where we tackle the projects and procedures that you, our customers, asked us to do. We've got two great projects for you today. One is on a hybrid vehicle. We think we've got one of the diagnostic challenges solved on high voltage circuits. You're going to love this. The other procedure is on batteries. We actually have conductive testing techniques today that you really need to learn about. Let's get started. Today's first diagnostic challenge comes to us from Ben at his shop just outside of Albany, New York. He wants to know how we can safely and accurately test high voltage cables to make sure that we're getting proper flow of electricity to the DC to DC converter. This Ford Escape Hybrid appears to have a unique problem. When we turn the ignition on, the voltage across the 12-volt battery doesn't come up like it should. So perhaps the DC to DC converter is the problem. And one of the first things we'll do is we'll check the output of the DC to DC converter right here at these terminals. We don't have any output whatsoever. It's at battery voltage. In other words, what we're getting here at these terminals is the same things we're getting across the battery. So the DC to DC converter appears to be the problem. Here's our diagnostic challenge. The DC to DC converter gets its power from the inverter converter assembly on this orange wire that's at 330 volts and up to 4 amps. And the inverter converter assembly gets its power from the high voltage battery in the back. So think about that for just a minute. The DC to DC converter is getting its power from the high voltage battery in the back. That's why there's 330 volts on this cable. And the diagnostic challenge is, how do we check this cable safely to make sure that we're getting proper input to the DC to DC converter? And here to help us today with a solution to that challenge is Steve White from Electronic Specialties. Is this the solution to our challenge?
Yes, I believe it is. This is our new Model 688 True RMS Premium Low Current Clamp Meter. And it is designed to measure low currents like you have there in that DC to DC converter wire, which would be under 4 amps. It will accurately measure that. Also, particularly the low current battery drains, which are becoming a problem in the automotive field as well. So it's been designed for those types of jobs. Yeah.
Wow, that's impressive. And I see it's Cat 3 insulation. So remember, this is a shielded cable now, Steve. So this thing can read a shielded cable?
Yes, it's a Hall effect sensor in here, so it should pick up the electromagnetic field going through that wire. It should not be a problem. Yeah, definitely what it's designed to do. Okay, for this test, what I'm going to do is I'm going to set the meter to the 5 amp range here. There's a 5 amp range and an 80 amp range. And for this wire, which should be 4 amps or less, we should be safe there. With any DC current probe, you want to zero it first before you clamp over the wire, so we're going to do that. And then I'm going to take and clamp it right there. So we should be good, and you should be able to go start the vehicle now.
Wow, that's actually fantastic. We got about 2 amps or so here, and that's kind of normal, somewhere between 1.5 and 4 amps. But the point is, we have solved our diagnostic challenge. This tool really works, and we now have a way to safely check high voltage currents on a hybrid before we condemn a very expensive component. Well, now that we've got this vehicle diagnosed, we can shut it off and begin our repair procedures.
I am on the phone every day with automotive technicians, and one of the biggest discussions we get into is conductance testing for all of the new vehicles on the road with sophisticated electronics.
We need to be aware of the technology involved. These newer vehicles, they've become much more complicated, and we need the tools to be able to properly diagnose those systems. And to help me with that today, I have Dan from Midtronics.
One of the keys with the alternator these days is where we've now got temperature sensors and current sensors that are mounted on the negative battery cable, so that the voltage control regulation is actually housed in the engine control module or the powertrain control module. Plus, those are what are known as transistorized alternators. Sometimes they're called pulse width modulated alternators. But what they're trying to do is kill the AC signal coming out of the alternator so it doesn't mess up the CAN bus architecture that's in the car, where the modules are trying to talk to each other in the more complex vehicles. So let's go ahead and get started at the battery and look at some of the details about this specific vehicle. We're going to go ahead and, first of all, when we take the tester, you can look at the clamps, and each of these clamps actually makes 2 points of contact. You've got the body of the clamp, which has 1 wire attached to it, and then the serrated edge in this clamp actually has a separate contact, because that's the power side. We're going to take and power the tester through the in-service battery, and we're going to inject a small AC signal into the battery. The test technology is called conductance, but that doesn't really matter. What we're worried about is whether or not we can get enough information from the battery to make a decision. Healthy battery, good recharge, recharge or retest, or replace. Okay, when we're connecting to the battery, we want to make sure that when we connect, that we take and move the clamps, rock them back and forth a little bit to make sure that if there's an oxide layer that we break that and get good contact on the terminals. That's both negative and positive. The tester automatically turns on and you see the voltage measurement that comes up on the screen. We're going to simply hit enter and we're going to go through the menu. We are testing in vehicle, so we hit enter one more time. It is a top post battery and it is a standard automotive style battery, and it is rated, it's a flooded battery that's rated in CCAs. All right, the last battery tested was at 600 CCAs, which is what's left in memory in the tester. So we'll scroll down to the 525, which is what this particular battery is rated at, and then simply hit enter one more time. The test takes about 5.6 seconds, and you'll come back with a decision. So here we have a good battery decision. That's all there is to it. And now it's asking if we want to move forward and do the starter and alternator test as well.
While Dan Cox is in the garage today, he's going to take us for a test drive of some of the new test equipment from Midtronics. And for that, we're going to bring in a 2012 Chevy Volt. A good tip is to take a piece of cardboard and cover the blue start button inside the car. This will prevent you from accidentally pressing the button while the high voltage system is disconnected. It's a simple tip that will save you from big headaches if it gets pressed while you're working on the car. The shutdown procedure for the Chevy Volt is to pick up the armrest in between the two front seats and remove the inner liner and move the little bag off of the master disconnect. Then, with your glove on, we'll press the release tab and remove the master disconnect. Be sure to wait about 5 minutes to give the capacitors in the inverter time to discharge before you do any further diagnostics or repair. Well, Dan, we've got the vehicle shut down, we've got the master disconnect out, and on the dashboard where we can keep an eye on it.
You bet.
And I've got the inverter cover off for you. And we don't need our high voltage gloves anymore because that's shut down. So what's our next step?
Our next step is actually to make the interconnect with the battery cable that goes directly into the inverter from the main battery. So I've got a 10mm wrench. I'm going to go ahead and start to remove that bolt right now to get that unplugged. There we go. We can pull this out, bring it up to the front. Okay, I've got the high voltage cable from the hybrid battery that plugs into the inverter. I've got it removed. Jim, why don't I go ahead and have you plug in the high voltage interface module and get it tightened up for me. Okay, the high voltage interface has been connected. Now we'll take this cable with the Cat3 connectors, plug it directly in the diffused interface box. Once that's complete...
And these are the fuses?
That's correct,
Okay.
the 372 volt DC. Now we'll take the high voltage interface cable, plug it into here. That completes our high voltage interface to the battery. Now all we have to worry about is the control side of it. So we'll look at the low voltage stuff through the VIM, the vehicle interface module. Let's go around the side of the car and look at that right now. We've got the vehicle interface module here, and we're going to disconnect the two control cables from the vehicle battery control module, bring them forward, and install them. They're color coded, blue to the blue, gray to the gray, just like it says on the screen. And we'll latch them in place. This is the cable that goes directly to the control box, and these are all the options that we've got to connect to inside the battery pack. So this connector just goes in like that.
Now to reinstall the service plug, or sometimes called the master disconnect, we simply put it down over its receptacle, push it down to engage the lock, put the protective cover over it, reinstall the inner liner to the armrest, and we're done.
Okay, now that we've got the high voltage and low voltage connections made to this 2011 Volt, we'll take the unit that's been programmed for General Motors. It's the EL50332 version of the GRX 5100. We're going to take and just go through the menu, and what we're going to start with is just an opportunity to depower. We're going to take a look at some of the energy that's available in the battery right now. So it's all menu driven, and some of the self-checks take a long time because it is a very complex battery system. All the handshakes have to take place before the unit's going to take any energy in or out of that battery. So let's go ahead and just start with the menu. Okay, the screen has D-Power. I'm going to select that. I'll select Chevrolet, select Volt, doing the self-test, internal self-test. I can't stress how important this is to make sure that all the systems, because we're dealing with high voltage, everything is connected properly and that the safety aspect is in place. But we're going to go ahead, we're on the entire pack, we'll hit next. And this is the interface, we're at the inverter module, that's correct. And it is on the hybrid power side, hybrid powertrain. I said we were going to do a discharge. We've got a target voltage of 280 volts. I simply hit next, and then it tells you, really at this point is when the software tells you how to make the connections. To save a little bit of time, we made the connections in advance. We'll go through and see what the screen says each time and just continue with the prompts. This is to go ahead and connect at the inverter, which you've already done. Then to go back and connect the black cable, the low voltage side, through the VIM, the vehicle interface module. And then install the manual service disconnect, again, which I've already taken care of. We hit next, and it's detecting the pack. So here we go, it's finishing, it's doing the USB drive. In other words, it's writing to the drive already. Any test that's taken place in this tool, the information all gets logged. That includes the VIN number for the vehicle and the battery number. Both of them have unique IDs, so if there were ever any exchange between the battery and the chassis, they would have that information. And right now, here we go. We're discharging at 7.5 amps. We started out at 373 volts. We're going to go down to 280 volts. When this is all done, it will stop. If there were ever a problem that the operator encountered for any other reason, we would have the option of simply terminating the operation. That disconnects everything with that unit, and then it points it out here. It's writing it to the USB drive, and you get the signal that the operation has been terminated. Okay, we've just completed testing this Chevy Volt with the GM specified EL50332. This is actually a chassis that's part of a family of products that are being developed for the high voltage industry, for the high voltage vehicle industry. So let's go ahead and shut this down. And after the operation, Jim, what did you think of that?
Dan, this was just awesome. All this technology, and we can still tackle these types of projects in our shops. Thank you so much for showing us this. Well, what we have to do is disconnect all the electrical connections and put the car back together, and we'll get this one on the road.
Sounds like a great deal, Jim. Let's go.